Greetings everyone. My name is Archana Vyas and today in this video we will be discussing about the topic bus arbitration. The contents we will be covering in this video are what is bus, why we need arbitration, what is bus arbitration and types of bus arbitration. So, first of all, bus structures. There are many ways to connect different parts inside a computer together. A group of lines that serves as a connecting path for several devices is called a bus. There are three types of bus: address bus, data bus, and control bus, and we will be discussing about them in further coming slides. Here in this picture, we can see that it shows that how the devices are connected inside the computer. As you can see that there are various components in the system processor. There's a memory, there's input-output devices. They are connected through a common group of lines. And these group of lines are nothing but bus. These set of lines are used to transfer the data from one place to another place. Means two units can communicate their information through a common bus. So bus can be defined as a group of wires. So this is a system bus and this bus can be categorized into control bus, address bus and data bus. Let's see what are these. There are always three sets of wires or bus in a computer. Like these three sets of wire are always there in a computer. Now, first of all, address bus. It is used to convey the value of the address. Then data bus. It is used to convey the information or the message or the data which is sent between the devices. The control bus. It is used for the control signals such as MREQ, read and write, etc. The collection of these three is called a system bus. Now, the system bus is a bunch of electrical parts that are used to convey electrical signals between various devices inside the computer. A bus or any bus cannot be used by more than one device at one time due to the electrical properties of the devices. The output will be connected together and will cause the damage. So the solution is arbitration. Before any devices are allowed to perform read-write operations using the system bus, it must first obtain the permission. So this is the main part of our topic, which is what is arbitration. To understand arbitration, let us understand some few components. A device that initiates data transfers on the bus at any given time is called a bus master, which is a very important component. In a computer system, there may be more than one bus master, such as the DMA controllers or a processor, etc. These devices share the system between, like this share the system bus, and when a current master bus relinquishes, another bus can acquire the control of the processor. So bus arbitration is a process by which next device becomes the bus controller by transferring bus mastership to another bus. In a multiple bus architecture, several components are connected through a bus, so they are requesting to transfer their data. So they are required the bus because only on the availability of bus the transformation operation will take place. So it's the responsibility of the controller to allocate the bus to a particular component. So there are various components which are having requested for the bus. That means bus request signals are issued by various components. But the bus grant signal is issued by the control unit to the particular component. So switching of the bus from one component to another component is called the arbitration. So here there are two types of arbitration we will be discussing today, which is a centralized arbitration and a distributed arbitration. So we will be discussing about them in brief in the coming slide. Centralized arbitration. Centralized arbitration is a single bus arbiter performs the required arbitration, which means that only one component is deciding to whom the bus is to be granted. The bus arbiter may be the processor or separate controller connected to the bus. Now, distributed arbitration. Here, all the devices participate in the selection of the next bus master. The distributed arbitration is highly reliable because the bus operations are not dependent on devices. So the only difference between them will be here the single bus performs the required arbitration, and here all the devices participate in the selection of new master. So this is a centralized bus arbiter. It has a DMA controller, two DMA controllers and a processor. And now this is a distributed arbiter. Now the three bus arbitration methods. There are three bus arbitration methods. They are daisy chaining method, pooling or rotating priority method, fixed priority or independent request method. We will be discussing about these three methods in brief. So the first and foremost, the simple and the cheaper method is the daisy chaining method. In this case, the bus grant signal serially propagates through each master until it encounters the first one that is requesting access. And first of all, the bus masters use the same line for making bus requests. This master blocks the propagation of bus grant signal. Therefore, if any others are requesting module will not receive the grant signal and hence cannot access the bus. During any bus cycle, the bus master may be any device, the processor or the any DMA controller unit connected to the bus. So let's understand with the help of a diagram. So in this case, there are several masters which are connected through a common line. Master 1, Master 2 and so on up to Master N are connected through a common line, and that is bus request and bus busy. So common line is used to connect all the masters and they can put their request through the bus request channel. Here it is where the masters can request for the bus, and if they get the bus and by transferring data they can inform this controller that the bus is busy through a bus busy line. So this method is very simple and cheaper, and very less number of lines are required in this one, which is the greatest advantage of this method, that it is simple and cheaper and it requires the least number of lines. But with advantages, there are also drawbacks in this method. We will be discussing about it. So here the components are connected through this common bus line, which is a bus request and bus busy, and they are putting their request to the bus request channel, requesting for the bus. But it's the responsibility of this controller to issue the bus request or to grant the bus grant signal. In this case, the controller grants the signal to the first master. As you can see, the controller always grants the bus grant signal to the first master. And from the first master, the signal will propagate. If the first master does not require bus, then it will grant the bus signal, and which will be issued to the next master. Here as follows, and so on. This way the bus grant will propagate. Like this master will grant the request to another, and so on. It will propagate. Since the bus grant signal propagates from master 1 to the next masters, obviously the slow arbitration will be observed, which is the first drawback of this method, that the controller first grants the bus grant signal to the first master. This first master will grant to the second one, and so on. which will take a very slow arbitration time. Then second priority depends on the second one is that the priority depends on the physical location. Like it's our second drawback that the priority depends on the position of master bus. Like there are one, two, three, and so on masters. So here we have an nth master. It is at the last. So it has the least priority, and it will also receive the signal, let the grant signal at last. This is one of the drawback. And the last but very important drawback of this method is chance of failure is more. Here we can see that if a particular master gets failed, like here if I say that this master gets failed, here if I say that this master gets failed, then it will not propagate the signal further, because if it fails once it cannot propagate the signal further, so the next masters will not receive the signal. The masters from here will not receive the signals. So if there is a failure, so if there's a failure in this one master, it will affect the whole system and it will make the whole system to fail. So if there's a failure in one, it will reflect the whole system to fail, which is the major drawback of this system. And to overcome these drawbacks, like we have covered all these drawbacks and the advantages, and to cover up these drawbacks, we have another scheme or another method, which is pooling or rotating priority method. So in this method, the controller is used to generate the address for the master, and the number of address lines required depend on the number of masters connected in the system. For example, if there are 8 masters connected, at least 3 address lines are required. In response to the bus request, controller generates a sequence of master address. When requesting master recognizes address, it activates the busy line and add begins to use the bus. Let's understand this method with the help of this diagram. Here we can see this in this case that the masters are connected through a address line. All these masters 1, 2 and 3 are connected to these 3 address lines. So separately address lines are used to connect different masters. So if there are n masters, we will require the number of address lines accordingly. As I said that if there are 8 masters connected in system, at least 3 address lines are required. So now, when this masters request, then they request through a bus request channel. And to acknowledge the controller, this is the controller, to acknowledge the controller using the bus about the if they receive the bus, then to acknowledge this controller, they pass the signal or the information through this bus busy line that the bus is busy. Here you can see that the masters are connected through the channel or the address line, which is the module address, this one. So the masters are connected through this. And the polling sequence is generated by the controller in this case. To whom the bus grant signal is to be issued is decided by this controller. It will decide that to whom it will issue the bus grant signal. There is a decoder which generates the polling sequence about to whom the bus grant signal is to be issued. And according to the polling sequence, the address is generated and the particular address is available on the address channel. So that if the particular master, such as this master, requests for the bus and the address matches with the address line, then address line or the address channel we can say, then the master can get the signal of the bus grant. So in this way, this methodology can be implemented. Now every method have an advantage or disadvantage. So The advantage of this methods are that it is a fast arbitration. This method is a bit faster than the previous method, which was daisy chaining. Then this method again is the simple one, and it is just like the previous one. It is a simple one, and also it has less chance of failure. Here, as they have a different address line, every master has a different address line. So if the failure of this will not affect the whole system to fail. So this was the drawback in the previous case, which has overcome in this case. Now this scheme also has a disadvantage as well, which is increasing the size require more number of address lines. Which means that if we increase the size of bus as increase the size of master, as if here we have taken 1, 2, 3, 4 masters, so like n masters are there, then the number of address lines will increase. So the eventually, if the number of address lines increase, the number of wires required will also increase. So this is one of the most important drawbacks of this method. And to overcome this drawback, again, we have another method, which is fixed priority and independent request method. In this method, each master has a separate pair of bus request and bus grant lines, and each pair has priority assigned to it. The built-in priority decoder within the controller selects the highest priority request and asserts the corresponding bus grant signal. Let's understand this with the help of the diagram. In this case, each master has a separate pair of bus grant and bus request channel connected to this controller. So this for master 1, this has a separate pair of bus grant 1 and bus grant request. Bus grant 1 and bus request 1, and for master 2 it has its separate, and so on for master n. But as far as but in the comparison of previous cases, similarly it has only one common bus busy line connected to the controller, so that they can acknowledge the controller about that. If a particular master receives the bus, it can acknowledge the controller that the bus is busy through this bus busy line. Now, whichever master is requested for bus, it can put their request separately to the controller. And there is a priority decoder which decides whose priority is high, and that particular component will be issued a bus for their transfer. So based on priority, bus grant signal is issued, and priority is decided by the priority decoder and the controller. So that is the major change that we can see in case of this method, which is a priority based method. So there are various advantages in this case. First, which is very fast arbitration in comparison to the previous one. With the previous schemes, it has the fastest arbitration, and it has a very less chance of failure, as every master has its own separate pair of grant and request channel. So if the one component or one master fails, it will not affect the whole system. Over here, it will not affect the other system to fail, because every master is connected to the controller with a pair of bus grant and bus request. So if the particular master fails, there is no effect on the whole system. But there are few disadvantages of this method also, one of which is cost is high. As there are, in this method, it's provided with a separate pair of bus grant and bus request channel for each and every master. So obviously, eventually the cost will become higher, and also it has a priority decoder which will add up to the costs. Now the second is the chance of starvation. As I said earlier, that the priority decoder will decide on the basis of priority, and whichever has the high priority will get the bus grant request first. So the low priority component just has a chance. Over here is mentioned that it has chance. So that the lower priority decoder just has a chance of getting the bus, but it will never get a bus because of the high priority masters in the system. So these were the advantages and disadvantages we covered for this method. In this video, we learned that how the components are connected to common lines called bus and how the bus can be arbitrated from one component to the another. And we also saw some various methodologies for the same. That's all from my side. Thank you.